this video, we're going to go over the study guide that your teacher gave you today. So, on your test is going to be something about double negatives. This is to change a negative exponent into a positive, you need to do the reciprocal, which is the opposite. It may be easier if you follow the quotient rule first if you have the same bases. So, the quotient rule, if you look at the top of your packet where the warm-up was, the quotient rule is right here. It says same base, keep the base, and subtract the exponents. So that's what we're going to do. I'm going to move back down here. So I know that both these bases are the same. So that means I can do my next step. So I'm going to take the exponents and subtract them from each other. So I have negative 6 minus negative 3. When I have two negatives next to each other, it's going to make a big old positive. So I know that if I owe you $6, I only give you 3. That means I still owe you negative $3. And we need to make sure we put the bases back because this is what our exponent is. So if I have a negative, we really don't like negatives. So that means I need to do the reciprocal, which is the opposite. Remember that there is an invisible 1 underneath the number. So I need to flip them, meaning I'm going to make it positive, the opposite. So I'm going to have 1 on top, and now I have 5 to the power of 3. The reason why it's not negative 3 is because I flipped it, thus to make it positive. Okay, give a second and see if you can do this on your own. So let's try it. Letting you know now, just because these are touching, it does not mean that they are going to go together. So I can break it down into parts, right? I have 6 over 12 times, I have x to the negative 4th over 1 times 1 over, and I have my x to the negative 2. So now I can reduce this. I know that these both go into 6, and I know that 6 divided by 6 is going to give me 1, and 12 divided by 6 is going to give me 2. And I know that since this is a negative, I need to flip it to the bottom. Since this one's also negative, I need to do the reciprocal and flip it to the top. So now I have x squared over x to the 4th. Now I can visually see I have 2 x's on top and 4 x's on the bottom. So I can cross them out, pair them up. I know that these are pairs, so those cancel. I know these are pairs, so it'll cancel. So what I'm left with on top is 1. What I'm left with on bottom is my 2. And how many x's do I have? Well, I have 1 and 2. So I have x squared. And that'll give me my final answer. So now we're going to move on to the equivalent equations. This is simplify and solve all problems to find which are equivalent. Equivalent means that they're the same, they equal each other. So we'll start with this first one here. Well, I'm dealing with a negative 3, so that means I need to flip it. Drawing the line and the 1 will definitely help you when you have a negative, so that way you can see that I do need to flip them. So this answer is actually a 1 over 12 cubed. So now I'm going to look at my other answers and see that, hey, you know what? I have the same answer here. So that means both of these are the same. Now I need to figure out which other one is going to be also the same. So in order to do so, I can take 12 cubed and simplify it, so solve it out. So I know that this means 12 times 12 times 12. I know that 12 times 12 is 144. And now since I have my other 12, I need to bring it down and multiply by that. So I have 144 times 12. 4 times 2 is 8. And I have 2. Then I'm going to go to my tens place, and I'm going to go 0, and 1 times 4 is 4. 4 times 1 is 4, and 1 times 1 is 1. And all I do is add. 8 and 0 is 8. 8 and 4 is 12. 4 and 2 is 6, plus 1 is 7. So I know that 12 cubed, this is actually also saying 1 over 1,728. So I have an answer that's just like that, which is this one right here. So I figured out that all three of these are equivalent, and I know that this one does not belong. Take a few seconds, and we'll move on to the next one. Now I'm on number 10. So we're going to compare with scientific notation. So we need to find the difference of the exponents and then simplify it. So on your paper, there is a times 10 to the 4th. This is actually supposed to be crossed out if you remember from class, and you're going to put a 4 there and then 3.5 to the negative third. So what you're going to do is we need to figure out that Jose is selling his candy for 3.5 to the power of 4 each, and Braden sells his candy for 3.5 to the negative 3 each. We need to determine how much more money is Jose's candy than Braden's. So that Jose sells 3.54 candies each, and I know that Braden, 3.5 to the negative 3. Okay? When I'm comparing these, I need to take both these exponents and subtract them from each other because I need to figure out how much more money is Jose's candy than Braden's. That's why we are subtracting. So I'm going to take 4 and subtract it from negative 3, right? And I have my 3.5 here as well. So two negatives next to each other are going to make a positive. So now I know that his is 3.5 to the power of 7 larger than Braden's. Okay? So think about it like this. He is at positive 4, right? And he's at negative 3. So from 3 to 0 is 3, and you add another 4 is 7. Okay? So for number 11, Ashley makes 5 times 10 to the power of 3 each year for her salary. Alexis makes 5 times 10 to the power of 8 each year for her salary. How much more does Alexis make than Ashley? Well, we can definitely compare these, right? So I know that these both have the same basis, correct? I know that they are both to the power 10 to the power of some number. So I can subtract 8 from 3 because I need to know how much larger, right, for subtraction, just like this one. 8 minus 3 is what? 5. So I know that Alexis makes 5 times 10 to the power of 5 more than Ashley each year. You could also break this out, and this is actually going to be 5, 1, 2, 3. So she makes $5,000, while Alexis makes 5, 1, 2, 3, 4, 5, 6, 7, 8. She makes a lot more, as you can see. But how much more? She makes 5 times 10 to the 5th more. Okay? So let's move on to the next one. So for this next one, scientific notation. Place the following in the correct order on a number line. There are several different ways that you can do this. One way you can do this is you can actually break out each of these scientific notation into standard form, or you can put this one into standard form. It is completely up to you. But do keep in mind that, yeah, it might be just a little bit more challenging for you to put this one in the scientific notation and then try to put all those numbers on the number line, but whichever way. So the way that I'm going to do it is I'm going to put these into standard form. So I know that this is going to be 1, 2, 3, 4, 5, 6. Oops. Let me make that a little bit larger for you. So I'm going to have 5 million. For the next one, I'm going to have 50,000, or sorry, 500,000. For this one right here, I have 7.5. 1, 2, 3, 4, 5. I have 750,000. And for this last one, it's 0.6. I have 1, 2, 3, 4, 5, 6, 7. I have 6 million. So first I need to figure out which is going to go first. Which one is the smallest one? And by looking at that, I notice that this one right here is smaller. So I know that it's going to go 500,000. Then my next one is going to be 7,500,000. And then for my third one, I know that, let's see, I know that it's going to be 4, because I already got those ones. So it's going to be 4 million. Okay, and then after 4 million, I have 5 million. And then my last one, 6 million. So in order to place these, what you can do is there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tick marks there. Okay, so I know my smallest number is 50,000 and my largest number is 6 million. What I need to do is determine how am I actually going to do this? Well, I can have 0 here. And then I'm going to have this one be, I'm going to count by 500,000. Okay, and then the next one's going to be 1, 2, 3. It's going to be 1 million. And then I have 1.5 million. And then I have 2 million. And then 2.5 mil. And then 3 million. 3.5. 4 million. 4.5 million. 5 million. And I can add a few more. 5.5 million and 6 million. So I know my first dot's going to go right here. And this one is going to be actually 5 times 10 to the 6. And my next one is going to be 75. So it's going to be pretty much closer right here. So this one is actually 7.5 times 10 to the 5th. So I got that one and that one. Now I have 4 million. I'm going to put a big old dot there. And I know that that one's already just 4 million. And then I have 5 million, which is going to be right here. And that was 5 times 10 to the 6th. And then I have my 6 million, which was 0.6 times 10 to the